Hello and welcome back. In this video, I want to go over quick explanation for the problem 5 of day 5 for Advent of Code 2023. The problem, let me explain the problem in brief with the example that is given to us. We are given this sequence. Let's say this value is x, this is the seed values, they are integers, and then we are given 7 maps, each of them. Let me explain what each of them does. So let's say this row is given, it is denoted by destination value, source value, and length value, and each of them denotes that uh, source to source plus length, this range is mapped to destination to destination plus length. This is the brief explanation of the inputs. So for each x, what we need to do is go over all of these maps first, second, in this sequence all the way up to here, and for each of them this x will be mapped to something. Let's say for the first map, which is this one, there would be some mapping like this. So all the values in this range would have been mapped to all the values in this range, and their lengths are equal. So x will go through this map, it would have been transformed to something else, then this map is done, then we do it for the second, then for the third, fourth, all the way up to 7, and after 7 we will get some values of x, and we need to find out what is the minimum value for x final over all the x that are possible from seeds, which is this array right here. Okay, to implement this, let's go over the part A solution. I have transformed this input to, let's say there are 4 seeds, right? So I have transformed it to 4, then a sequence of 4 integers, then there are 7 mappings. This 7 is constant, hence I have counted these rows. So 2 rows, then each of those 2 rows has 3 integers, so sequence like this. Then again this has 3 rows, then 3, then again 3 rows each with 3 integers, and so on. This is how I have transformed the input, and this is how I will pass the input in the C++ implementation. And after this is done, the initial sequence, which is on the first line, will be stored in this vector, and the ranges of, let's say, destination, source, and length would be stored in this, and there are 7 mappings. Hence this is how the values will be stored, and this is the 3 length row. After this is done, I will go over all of these seeds, initialize x with that, and this x will be mapped for all the 7 mappings starting from 0 all the way up to 6, and for each of them we check whether that particular x lies in the range of mappings that are possible for that particular range. And if that is the case, then this will map to something else, right? And to figure that out, we simply find out the difference and change x to that value, which is mapped to something in this particular range as x dash, and this x dash would be the input to the next mapping. So we update x in place, so, and break the for loop for saying that we found out a mapping for this particular index, and we continue the process for all the 7 mappings. And after all of them is done, we find out what is the final value for x after all the mappings, and we try to minimize them over all possible initial starting points, and this would be the final answer. Now part 2 demands us that instead of starting at some x, we are given seed, we will use the same input, but this has an even length, and the sequence is something like this. So let's say S1, S2, S3, S4, like this. If this is even, so 2n minus 1 and 2n, and we need to treat these two pairs one after the other, and so on. So the first value denotes, what does it denote? Yeah, so the first value denotes that this is the starting value for x, so, and this is the length of that particular interval. Now this is one range for values of x. So initially x was fixed to be some seed, right, in this sequence, but now x belongs to this range, start to start plus length. Now x belongs to this range, and for all possible values in this range we need to perform the same operation of mapping. But if we naively implement this, so instead of this seed, we will, if we simply go over all x in that range starting to start plus that length, then this is very inefficient. This is the naive approach. This is inefficient because this length is of order 10 raised to 7 as well, or even 10 raised to 8 in some large inputs. So this for loop may run about 10 raised to 9 times or even more. Hence, this is an inoptimal solution, and this will take a lot of time if you try to implement this. So I figured that this is not the intended solution, and let's try to figure out how we can solve this efficiently. Now, let's try to visualize for part A. We did something like this. Initially, x was simply an integer, right? For part A. For part A, x was an integer, and there were some mappings available to us. Let's say these were the mappings. Let's say this was mapping for the first map. Then there would have been some more for second, and so on for the seventh one. Now, this x should have been matched with some range in this map, and then it would have been transformed to some value in this position. Let's say x1. Now this x1 becomes input to this. It would have been matched, or if it would not have been matched, then it remains the same, and so on. So this was our algorithm for part A. Now for part B, instead of x being an integer, x is a range. So the seed values, as you saw, this is the range for x for a particular pair in this sequence. Now x is some range. Let's say it is capital LR. Let's say this is the range. Now if you perform the same thing here as well, so let's say this are the possible mappings. So these are ranges from which x is transformed to x dash. You need to read the questions thoroughly to understand this statement, but the main idea is to say, let's say x was 10, and these ranges are transformations from, let's say, 10 to 20 is transformed to 200 to 220. Let's say x is 15 in this case, then x 15 lies in this range, hence it is transformed to 205. So once if x belongs in this range, it is transformed to the same corresponding location in this right range. So this is what a particular operation or mapping denotes. So this is what is given in the input. This sequence is given to us. Now let's say for some particular mapping, this is for map 1, this is given to us. Now x, since x is a range, it can match with multiple of these ranges. This is the first idea. It can match with this or this. So let's say it matches with this particular range, and there was some transformation for this. It matched with this. There was some transformation with this. It would have also matched with a larger range whose transformation was something else. And this is the values of x that we need to check for particular mapping, right? So for the first mapping, if these are the possible mappings that we need to look at, then let's see how x changes. So let's say x was this range, this large range, and we had these mappings, these, let's say these. For this one, it is simply saying that this values in this range should be transformed to this mapping, right? So let me denote this as 1, and then the values in this range should have been mapped to, let's say, value this mapping. Then since this goes outside the range of x, so we only need to consider this. So all these values will be mapped with the mapping of this range. Next, if this entire thing was to be considered, then actually there is one more constraint, that these ranges will not be overlapping, because there can only be one mapping from x to y, not multiple of them. So these ranges will be disjoint. So this would be disjoint. That would be the question. That would be handled in the question. So we basically turns out that we have two types of mappings that are possible over a particular range. So if this range matched with some of them, let's say this with first range, this with second, some of this with third, first, second, third, then the leftover part, which is in the red region, remains the same. So let's say these were values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 4 and 5 would have been mapped to the value that is corresponding to range 1. 8 would have been mapped to value that is corresponding to range 2. 11 and 12 would have been matched with the corresponding values that were possible for the mapping of range 3. But all the values in the red part would remain same, because if we don't find a mapping, then x dash is x. This is given in the question if mapping not found. So this was the case, and if it is found, we simply map it with the values as per the algorithm we used in part A. And essentially we don't need to map every integer, we just keep track of this L and R's. So there would be some endpoints for each of those fixed ranges. Then this would transform, let's say initially x started with L and R, then x would split again. It would become this region union this region, this region, this and this. So it now becomes 1 to 3 union the mapping. Let's say the mapping is f1 for 4 to 5 union with again 6. I'm denoting 6 to 7 as it is because they lie outside of the mapping not found, inside the mapping not found condition. Hence I have not performed any type of mapping on them on that range. Then 8 lies in this range, so let's say f2 was the mapping that was uh, considered for the values in this range, 8 to 8. Then we have 9 and 10, which lies in the red region, hence this would be the case, and f3 for 11 and 12. This is how our x transform. X initially only had one range, then in the next iteration, so let's say start, then x belongs to a union of multiple of them, and subsequently we need to consider for each of them, since they are disjoint, this ranges must be disjoint. We will consider all of them, check their individual mappings, split them. We have to check their individual mappings, split it across as we saw in this approach, and then update x again, and keep on doing this until we perform all the mappings. This is how the implementation looks like. Let's try to look at the code for part 2. The input implementation remains the same. For each count, we take in the sequence of seeds, which was a pair S1, S2, S3, S4, so on, where the first value was what do we call it? Start and total. Start, second was total, and this gave us x which belonged to a range from start to start plus total, right? And for each of these pairings we performed the mapping from x to x1 to x2 all the way up to x7, which we need to minimize. So we need to find out the minimum possible value of x7, where x belongs to this range right here for all the pairs. This ranges implementation, this is for input. Okay, I'm checking whether the length of sequence is even so that the input is valid. Next up, we find out the start and total for a particular pair. The left and right endpoints for that pair would be L and R. So now we have fixed x belongs to L and R, and x ranges from this particular, right? So initially there is only one range in this x. The values that x can take belong to only one single continuous range, which is from L to R. Hence this is added in the x ranges vector. And after that we perform 7 mappings, one after the other, and each mapping will split the range of values from x, and all of them would be updated again for the next iteration. For that I have kept track of the intersections and the new values of the x ranges, and after the current iteration is changed, I will update the x ranges for the next iteration with the new values that I have considered. Now we go over all the ranges LR. So x belongs to this, so this is what we are going to iterate over, and we will find out the intersections of all our mappings in the current iteration. So let's say we are currently mapping for the first, then in that mapping we will have some of these ranges, right? So we will have some ranges saying that you need to map L and L to R to some values in the right. And the one thing that we need to consider is, so if there is some range this and there is some range this, then the intersection part will have been mapped to something else, and the rest of the part remains same. So since the rest of the part can be covered by a letter indices of ranges, so if I just now say that this is the intersection but these are not, but we are iterating over a range of a sequence of ranges, right? So this part could have been covered by another range in this for loop. Hence, what I'm currently doing is I will find out all the intersections, so all of them, and after that I will find out what are the leftover parts, which are the gaps between the intersections. That is how I am going to find out the mapped uh, ranges and non-mapped ranges. Right, so if we find an intersection, so this intersection will return us the coordinates of ranges for the intersection between L1, R1 and L2. It will give us a range which will have the range endpoints for the intersection, and if it is not -1, then we found a overlap which lies in this particular range. So let's say LLRR, and since this is an over intersection, we are going to consider it from the original ranges start and end. So the intersection was from this to this, hence we add that particular in the intersections. And since this is an intersection, so there has to be some mapping that changes this to this, right? So this has been mapped since this is an intersection, and this is what we are going to update in the new X ranges. And once all these intersections are found out, I will sort them. So since all of them would have been disjoint as per the constraint in the question, so they would look something like this range, then this, there's something here, then we had some starting and ending, right? And after that I will start at the L, we need to end at R. So at each XY for this intersection ranges, I will keep track of what is the range that is non-covered, which would be this red portion. And this is the range whose mapping is not done. So these are the unmapped values of X. And for them, X dash remains the same. Hence, I have simply updated the new X ranges with the same values of those coordinates. And this is how the intersection ranges would be covered, and sorry, non-intersecting ranges would be covered, and this in here we have considered the intersecting ranges. This would be the case where this last non-intersecting range is considered, and after that we'll update the answer. And once we have all the values that X can take, now X belongs to a set of ranges. So this range, this range, this range. Now X can take any of these values, right? And once we are done with all the mappings, so X1 would be some list again, and X7 will end up at something like this. Now X can take any of these values, so we just need to find out the smallest one. So the smallest that can take is the small left coordinate of the smallest range. Hence, I have sorted the X ranges after performing all the mappings. Notice that this is after all the mappings that have been performed, and after that I will sort and take the smallest X and update it in the answer. This iteration is performed for a particular pair of ranges that we saw, which was this. So if when we find out x7 we minimize the answer, then we perform the same for this pairs one after the other, and this after doing that we'll print the answer. This is how the implementation for part B looks like. This was a fairly challenging problem as compared to last year's, since this is only day 5 and I think they have leveled up the difficulty too much. So let's hope for a good learning opportunity this year. That's it for this video. If you have any doubts or suggestions, do let me know in the comments. Thank you.